Welcome to part 2 of the neural network tutorial. In this video, we're going to create a neural network completely from scratch. And when I say completely from scratch, I really do mean it. We aren't going to be using any libraries for this. No NumPy, no TensorFlow, no PyTorch, none of those things. So this should be useful for basically any programming language, because my goal with writing this code wasn't just to make a neural network, but rather I wanted to write the code in a simple way that hopefully makes sense to anyone that tries to follow it. If you haven't watched part 1 yet, I would recommend starting there if you don't really know exactly how a neural network works. A link to part 1 is in the description. But okay, let's get started with the code. To start off, we're going to make a new file, and in it we're going to be making a neural network template. Here we have our empty C# file. However, as I said before, don't let C# scare you away, because we're going to be programming at such a low level that it really doesn't have any complex language specific things going on. This line here is just what Unity needs to work, and then this is just our basic class that comes with the file. To start off with our template, we need a way to store all of the values in our network that are important to us. So if you remember before, we have layers, we have nodes, we have weights and biases, and that's pretty much it. The layers aren't actually a thing, but they're a group of nodes. That's how I'm actually going to set up this code. I'm going to use layers to group our data together. So to do this, we're going to create a layer class. And in this class, we are going to be putting arrays to store the information I just mentioned. So we have our weights here. The weights array is a 2D array. The size and shape of this array depends on the number of nodes in the current layer and how many inputs each of those nodes are receiving. This first index would represent what node we want, and the second one would represent which weight we want. So we have two more of these arrays. This is going to be the biases array. And then we also have the float array. Okay. Both of these arrays are 1D arrays because they each only have one value per node. So the first index of all of the three of these is which node we're talking about, and then the second one in the weights is which specific weight we want. So our node array actually starts off empty until we actually compute the values for our network. But the weights and biases start off with values in them, which you receive from training a network. But for now, let's just pretend that we have good weights and biases from a pre-trained network. We'll work on the training portion later on. We're going to need to create a new instance of this layer for every layer that we have in our network. And since those layers can have differing numbers of nodes and inputs, we need to provide each layer class with information so that way they know what size to make these arrays, because you have to declare those in advance. To do this, we're going to make a constructor function. So we're going to need to give this constructor function some information. So we're going to give it actually the number of inputs. I'll make that n inputs, and the number of nodes in the layer. We're going to call it n_nodes for the number of nodes. Now inside of this, we need to initialize the sizes for our arrays. We'll start with the weights array, and this array, we want n_nodes and n_inputs. Okay, and then for the biases array and the node array, these two arrays we can actually do at the exact same time because they are both going to be the same shape, because they both depend on the nodes and not the inputs. That is just going to be n_nodes. Okay. I'm actually going to add one more thing to this layer constructor because I actually want to save these inputs and nodes after we get them, so the layer class can have access to it later. To do that, we're going to make some private variables. We want the nodes and we want the n_inputs. And now in here, we could just say this dot n_nodes equals n_nodes, and this dot n_inputs equals n_inputs. And this is just going to be useful for later on. And that's it for our constructor function. In Unity, there are some built-in functions that exist to help make games, and there's this one function called awake. And what that does is anytime that an object is created with this script running on it, it will run this awake function automatically. To make this, we just say public void awake. Now, anything we put in here will happen when we start our object, or like our creature gets born, basically. So in here is where we'll actually create our layer objects. We want to make a layer object for every layer that's in our network. The only layer that I don't make an object for is the input layer, because technically that's not really a layer, it's just numbers, and they're already calculated because the nodes already have their values. They're the input nodes. So I'm actually going to initialize these layer objects at the top of the file. So these are going to be all public. They're all going to be layers. That's our class. And we're going to have hidden 1, hidden 2, and our output layer. So hidden 1, we call the constructor on it by saying that hidden 1 equals a new layer, and this is where we give it the shape. So if we look at our neural network, you can see that the hidden 1 has 2 inputs and it has 4 nodes, and that's how you get these values. So hidden 2 works the same way, except now it's going to be 4 nodes and 4 inputs. And then finally we have our output layer, and this is a new layer as well. And this one has 4 and 2. I'm just using this network as an example, but we might change the shape of it later on depending on what we need for our simulation or what we need for any other project. Now we have this being created, and we can use our layer objects now. So I put the awake function in the wrong spot, so I'm actually going to put it below our class instead of inside of it. Normally you'd put this maybe at the top of the file, but I'm just going in order of what we're creating so it's easier to follow. Okay, so now we're actually going to add some functions to our layer class. We're going to have the forward pass and the activation function. Let's start with the forward pass function. We're going to say public void forward pass. I'm just going to call it forward for simplicity. And the reason that we don't need to return any values from any of these functions is because we're actually going to be manipulating this node array instead of returning the values, because we have access to this node array in this class. What goes inside of here is actually the most important function of the neural network. The forward pass function is going to be the function that executes that neural network equation that I talked about in the previous video, which is the sum of the weights times the inputs plus the bias. Since this function actually needs to use the inputs from the previous layer, we will add the inputs as an argument to the function. Now when we call this function, we give it the correct inputs that it needs. In order to do the forward pass, our function will need to perform the equation on each node in our layer.
Okay, so let's focus on the first layer that we need to do this for, and that is the first hidden layer right here. I'm going to give the nodes in this layer a number starting with 0. We'll also be using the previous layer as the inputs to this layer, so I'm going to number those nodes as well, starting with 0. These two sets of numbers are going to help us identify the nodes, the inputs, and the weights that we need to calculate the value for the node using our forward pass equation. You may notice that we didn't number any of the weights, and that's because we could use the node numbers to represent which specific weight we want. So if we want to look at this weight right here, this would be weight 0, 0, because it connects the hidden node of 0 to the input 0. This second weight would be 0, 1, because it connects the node 0 to the input 1. Since the weight and the input are related using the same variable, that will help us later on when we're looping over our numbers.
All these numbers we just added represent the indexes for the arrays we created previously. These numbers are our node and biases array, this is our input array, and this is our weight array. In order to go one node at a time, let's make a loop that will loop over all of the nodes in our arrays, because they all start with these node values. So let's make a loop. We'll make it a for loop. If I is less than the number of nodes that we have, and this value we got from our constructor function, then we keep looping until we get to the number of nodes. Okay, so inside of this loop, we're going to have to do the sum of the weights times the inputs plus the bias, because this loop is just what we do per node, and on each of our nodes, we're gonna have to do that equation. So let's start with the sum of the weights times the inputs. So since we wanna get a sum, we're gonna have to loop over all of our weights and multiply them with the inputs and track the sum. We're gonna need another loop for that. We're gonna say for j equals 0, and then j is less than the number of inputs that we have, so n inputs. We keep going. And now what we could do is we could store the sum for our node on the actual node itself. We have the node array. We're on node I. We want to store the sum in node I. This is gonna plus equal weights array sub I j, hope you're following me, times the input. So when we call this function, we actually have to give it inputs. And this inputs array is going to be the same shape as the j index of our weights array, because this represents the inputs and this represents the nodes. So this is going to be j of the inputs array. So now we're doing the sum of the weights times the inputs, and now we need to add the bias. To do that, all we have to do is add one more value to this node array of index I. We're going to use the same index I, and we're going to continue adding to it. We're just going to add the biases array, and this is going to be index of I, because if you remember, the biases are on the nodes, and I represents nodes, J represents inputs. There's one more thing that we're going to want to do, and that's because we keep adding to this node array value. What we actually want to do is we want to just reset this node array every time we call the forward pass function. I'm just going to say node array equals new float n underscore nodes. So that's just going to write over the node array every time we start this. You know what, let's just capitalize this. That's been my naming convention so far. Okay, cool. And that is our forward pass, arguably the most important function in the network. And now we have to add our activation function. The activation function is actually even simpler than the forward pass function, because we're using an activation function called relu, and basically all that it does is it goes over each of our nodes and checks to see if they're negative, and if they're negative, it makes them 0, and if they're not negative, it just leaves them alone. So you get this graph that looks like a slanted L, I guess. So we're gonna loop over each of our nodes again. In this loop, all we have to do is if node array of I is less than 0, then we just say it's 0. We say node array of I equals 0. Otherwise, we don't do anything. So this is literally it. This is our activation function. We call this on our class, and it will loop over all of our nodes. And if that node is negative, it makes it 0. Now that we actually have our forward pass and our activation function on our layer, we can actually go on to the next cool thing. And this is going to be a function outside of the class, and it's going to return a float array, because this is going to be our outputs of our entire network. So we want to get all those values for the output layer, and that's what we're returning here. And this, I'll just call it our brain function, because this is where basically the whole brain is going to live. The whole neural network is going to be in this function. And we're going to put this inside of creature, which is why I'm calling it a brain. We need to give this function our inputs, and it gives us our outputs. This function is the one that you could treat like a black box, where the neural network lives inside of it, and you're just using this function to try to do something. You don't really care how this function works, except we did, and that's why we did everything else. But when you're using this function, you don't care how it works. It's the black box neural network that you normally think of before you learn how to make it from scratch. Inside of this brain function, we're gonna need to do our forward passes and activation functions like we do in the network. So first we need to do our forward pass activation function for this layer, and then we move on to the next hidden layer and do the forward pass and activation function. And then we move on to the output layer and we do our forward pass. And I'm actually not gonna do an activation function on the output layer, but you can if you need to. I actually want there to be some negative values, and I probably could have used sigmoid to do that instead, because by doing this at the end here, just not having an activation function, they're actually gonna be more likely to be positive than negative. Basically, you just don't have to use an activation function unless you want to on the last layer. Let's do that in code. We do hidden 1, which is our first hidden layer. We're gonna call that forward function that we built into the class, and we're gonna give it inputs. And in this case, this is the first layer, so we give it the actual inputs to the entire brain. Okay. And then after we do the forward pass, we just do the activation function. And that doesn't need any inputs, it just triggers it. Then we do the same thing for hidden 2, except now the inputs to hidden 2 are the outputs from hidden 1. So if you remember, we didn't really have an output array. It's really the values that are in our node, because we stored the activation and forward pass functions in this node array. Basically, we just use the node array of hidden 1 to be the inputs for hidden 2. So that's what it is. Right here we say hidden 1.node array is the inputs. Then we do the same thing for hidden 2, where we just do an activation function after. And now we just do the forward pass one more time for our output. And this time it's going to be hidden 2's output array. Okay, let me put my semicolons that I missed, and that's it. I do want to return the final output array, so that would be the node array for our output array. We're going to say return output dot node array. And now we could use these outputs to interact with our environment in the evolution simulator. Okay, that's it. That's our neural network function. So before we actually move on to the training and the evolution simulator, I actually want to go through this code one more time and fix some things that I left purposefully simple so they were easier to understand at the time. But I want to make this template really expandable and not hard-coded, so that way you can make networks of any shape or size. Right now, you can see places like here, we just have the shape of this network hard-coded here. Technically, this is hard-coded because we specifically made layer objects for our layers, so that doesn't make it easy for us to make new layers. So basically, instead of having each layer be its own variable, we'll just store all of our layers in a layer array. So now we could use this layer array instead of adding a new variable for each layer that we need. So this makes it very expandable in terms of layers. But now what if we wanted different numbers of nodes inside of each of these layers? Right now, we have that hard-coded in down here where we say what size we want our nodes to be. So we could instead store this information in another array. We're gonna say public int array, because this doesn't need any layer information. This is just numbers. And this array, we could call it the network shape. So this is where we'll technically hard code the shape, but it's going to be adaptable. So if we wanted to recreate the same shape that we currently have, it would be 2, 4, 4, 2, because that is how many nodes we have in each layer, including the input layer. We do put the input layer here because we do need to know how many inputs we're getting. So now we could use these two things to replace anywhere that we used hidden layer. So it's really just down here. So my camera just died, and I'll just continue this part because I'm about to finish up. Okay, in our awake function now, we can use that layer array. So I'm actually going to want to initialize it to be the length of the network shape layer.length minus 1. What I mean by that is for our network shape, we actually have 4 layers, but I don't want to count the input layer. We're just subtracting 1. Now we could use this in a loop where inside of this loop, we go 3 times in this case, because we only have 4 layers and we don't do the input. Each time we're setting up a new layer. And the way we're setting this new layer is by calling the constructor. So we want to say that this first layer, if I equals 0, it would have 2 inputs and 4 nodes. What we do is we get network shape of I and network shape of I plus 1, because if we go up to the top, we'll see that that is 2 and 4. This little loop here replaces all of these. And now when we change the length of our network shape array by adding more numbers, like we could add any numbers we want, it would just automatically make all these layers. I don't have to make variables for them. And that's why this is better to do. Now let's do the same thing for the brain function, because these are still hard-coded. Okay, in order to replace this code, we're gonna need to loop over all of our layers again. So we'll add this loop here. So there are actually 3 different cases that could happen. So we have the first layer after our inputs. This one's different because it gets the inputs directly from outside the network. We need to handle that case. The second case is when a hidden layer is connected to another hidden layer, and I'll consider that like the normal case. That's the case that will happen the most often, because you could have many hidden layers in a network. And then the third case is for our output layer. We actually just don't want to do an activation function. But what that looks like in the code is, for the first case, if I equals 0, that means that we're on our first layer after the inputs. All we do differently here is we just do the forward pass, giving it the inputs. And then the next case would technically be this one, where we have our normal case, but since that's normal, I'll make that the default option in our else statement. So we'll handle this next, the output.forward. In order to handle the case of being in the output layer, we'll just say if I equals layers.length minus 1, which is the last element in our array, then we just call only the forward pass with no activation function. And the final case is our default case, where we just do the normal forward pass with the activation function, where the inputs to this layer are the outputs of the previous layer. And that's what we did here too. We did the outputs of the previous layer for the final output, but again, we don't do the activation for that. And that's about it. But now we actually have to replace this return instead of saying output array. So we'll replace that with the last layer in our layer array. And that is our network that has been made very expandable. So now you could literally make any size network you want just by changing these numbers. All right, so now we have our neural network and the tutorial is complete. But we have to train this guy, because right now this is just a template for a neural network and you could train it however you want. So in the next video, part 3, we're going to train it using an evolution simulator, which is probably one of the most basic, simple ways to train a neural network, which is why I think it's a great place to start. If that sounds interesting to you, subscribe and hit the bell, and I will see you guys in the next one.